we'll start with the session. It'll take 2 minutes to solve this question. They have given two conclusions, conclusion 1 and conclusion 2, and they have given two statements, and we have to see whether which conclusion is valid. So the first statement says that all numbers are divisible by 2, and the second statement says that all numbers are divisible by 3. So we have that rule. The rule for divisibility of 6. So rule for divisibility of 6 says that it should be divisible by 2 and it should be divisible by 3. So all numbers here, all numbers are divisible by 3. Are divisible by 3. Sorry, are divisible by 6. So because all numbers are divisible by 2, because all numbers are divisible by 3, all numbers are divisible by 6. But we cannot, the second conclusion is, we can conclude this, that all numbers are divisible by 6. Second conclusion is all numbers are divisible by 4. We cannot conclude that all numbers are divisible by 4 because, for example, if we take 6, 6 is not divisible by 4. Numbers which are divisible by 2 and 3, for example, those will be divisible by 6. For example, 6 3s are 18. So even this number is not divisible by 4. This is not divisible by 4. This is not divisible by 4. But these are divisible by both 2 and 3. So we cannot conclude this. So logically what follows is only conclusion 1. It is option A. So the correct answer is option A. I hope this is clear. If you have any doubts, please ask, or else we'll move to the next question. We'll move to the next question then. So take 2 minutes to solve this question. We'll see how to go about this question. What they're saying is if 3 raised to 2 2019 is divided by 10, then what is the remainder? So what is the remainder? That means they're asking the units digit. The units digits is the remainder, and to calculate the units digit, what you have to do is you have to find out the cyclicity of the power of 3's. So 3 raised to 1 is 3. 3 raised to 2, the unit digit is 9. 3 raised to 3, unit digit is 7. 3 raised to 4, the unit digit is 1. This is units digit, not the number. After this, it repeats again. So the cyclicity is 4 here, and if you get, when you divide the power by 4, if you get the remainder 1, you would get the units digit as 3. If you get the remainder 2, you would get the units digit as 9. If you get the remainder as 3, you would get the units digit as 7. And if you get the remainder as 0, you would get the unit digit as 1. So I have 2019 here, and when I divide it by 4, this is 4 1s are 4 5s are, and then 4 4s are 16. The remainder is 3. This is 54 into 4 plus 3. It gives you 2019. 4s are 16. 4 5s are 20, 21. So this is 20. This is 504. Sorry. This is 504. Measure 4 into 4. This is 2016 plus 3. This gives you 2019. The remainder is 3. So when the remainder is 3, the unit digit is 7. The correct answer is option C. I hope this is clear. If you have any doubts, you can ask. If there is no doubt, we'll move to the next question. Yes, when you divide by 10, you would get the remainder as the units digit. For example, if you divide 243 by 10, you would get the remainder, it's 3. If you divide 19 by 10, the remainder is 9. That is the units digit. That's why this question is indirectly asking what is the units digit of 3 raised to 2019. I hope this is clear. If it's clear, we'll move to the next question. I'll move to the next question then. It'll take 2 minutes to solve this question. So we'll see how to go about this question. They're asking for what value of n, the sum of digits in the number 10 raised to n plus 1 is 2. So what is 10 raised to n plus 1? They're asking what is the sum of the digits of 10 raised to n plus 1. For what values of n will it be 2? So if we see 10 raised to any power, any integer power, or any number, for example, 10 raised to 1 would give you 10, 10 raised to 2 would give you 100, 10 raised to 3 would give you 1000. And if you calculate the sum of the digits, it will always be 1. For only numbers, even for 10 raised to 0, 10 raised to 0 would give you 1. So for any number which is from 0, 1, 2, and 3 and so on, any power of 10, where n is equal to 0, 1, 2, 3 and so on, 10 raised to n would give you the sum of the digits as 1. And after that, if you add 1 more, then the sum of the digits would be 2. So clearly for any number which is from 0 to positive integers, 1, 2, 3, so on, the sum of the digits of 10 raised to n plus 1 will always be 2. So it is not that only for n is equal to 0, and even for n is equal to 1, the sum of the digits is 10 plus 1. This is equal to 11. 11 is 1 plus 1 is 2. 100 plus 1 is 101, and 1 plus 1 is 2. Again 1001, 1 plus 1 is 2. Like this for any whole number. What is whole number? Whole number is natural numbers, but in natural numbers, if you include 0, it will become whole numbers. So the correct answer is option B, not option A. Even for 1, 2, 3, other set of other numbers in the whole number set, this answer would be true. That is, the sum of the digits would be 2. I hope this is clear. If you have any doubts, please ask. For any real number, real number can be decimals. If n is decimal, this won't be the sum of the digits won't be 2. And they are saying for any positive integers only. No, even if 10 raised to 0, the sum of the digits would be 2. 10 raised to 0 is 1. So 1 plus 1 is 2. So even for 10 raised to 0, because this only is there, they're saying that only positive digits, any positive integers n would give you the sum of digits is 2. No. There is for n is equal to 0 also, this would work. So 0, 1, 2, 3, 4 like that. So that's a set of whole numbers. This is 0, 1, 0 plus natural numbers would give you whole number. This set is called whole number. I hope this is clear. If you have any doubts, please ask. Okay, then we'll move to the next question. Take 2 minutes to solve this question. This question. So what they're saying is how many pairs of natural numbers are there such that the difference of whose squares is 63. So they are saying there are two natural numbers. There are a pair of natural numbers whose difference is 63. So x square minus y square is equal to 63. So this can be written as x square minus y square can be written as x plus y into x minus y is equal to 63. So x plus y and x minus y has to be two integers, and when they multiply, it will give you 63. We'll find out the prime factorizations, prime factors of 63. 3 2s are, 3 1s are, 3 7s are. So 63 can be written as 3 square into 7. So there is one more concept, that is the number of factors. So for example, if you take 6, the factors of 6 is 1, 2, 3 and 6. So there are total 1, 2, 3, 4. The total number of factors is equal to 6, and there is a formula for this. So what we have to do is we have to bring the 6 in prime factors form. That is, 6 can be written as 2 into 3, and this will be 2 raised to 1 and 3 raised to 1. What we have to do is we have to add, for example, this, if this is 2 raised to a into 2 raised to b, sorry, 3 raised to b, we have to add 1 to this. Number of factors, total number of factors is given by a plus 1 into b plus 1. This is the formula. Like for example, the prime factorizations can be for any number. In this case, the prime, if you convert the 63 as prime factors, 63 is equal to 3 square into 7. So the number of factors would be 2 plus 1 into 1 plus 1. This is 2 plus 1 and this is 1. 1 plus 1. This is 3 into 2. We have 6 factors. So what are those factors? I'll just list the factors here. One is 1. After that there is 3. Then there is 7. Then there is 9. Then there is 21. Then there is 63. There are 1, 2, 3, 4, 5, 6. 6 factors are there. Now 63 can be written as 63 into 1 is equal to 63. It can be written as 21 and 27. This can be written as 21 into 9. It is equal to 63. 21 into 3. 21 into 3 is 63. And 9 into 7 is 63. So these are the 6 factors: 63, 1, 21, 3, 9, 7. And 63 can also be written as 63 into 1, 21 into 3, 9 into 7. Now these numbers, we consider it as whether it is in the 6 x plus y into x minus y is equal to 63. So we'll take one by one. So first case, 63 into 1. 63 into 1 is 63. So we have x plus y is equal to 63 and x minus y is equal to 1. This is 63, x minus y is 1. So now if I cancel this, this is 2x is equal to 64, x is equal to 32, then x minus y is equal to 1, 32 minus y is equal to 1, y is equal to 31. So here x is equal to 32, y is equal to 31. So x plus y is 63, x minus y is 32 minus 31 is 1. This is 63. So those two natural numbers would be 63 and 1. And then that is one pair. I just write it here. 63 and 1 is one pair. And then we have to find the second pair is 21 and 3. So again 21 into 3 is 63. So x plus y is equal to 21. X minus y is equal to 3. So 2x is equal to 24. X is equal to 12. X minus y is equal to 3. 12 minus y is equal to 3. Y is equal to 9. So again, these two are coming as integers. So this can be represented as x plus y would be 12 plus 9. It is equal to 21. And 12 minus 9, x minus 9, 12 minus 9 is equal to 3. So another pair is 21 and 3. So the next pair would be, we'll check whether this will satisfy this x plus 1, x plus y into x minus y. That is 9 into 7. X plus y is equal to 9. X minus y is equal to 7. 2x is equal to 9 plus 7. It is 16. X is equal to 8. So x minus y is equal to 7. And this, so 8 minus y is equal to 7. Y is equal to 1. So this can be written as 8 plus 1. This can be written as 8 minus 1. So again, this number can be written as product of two natural numbers. It is 9 and 7. So there are just three factors that satisfies the given condition. The correct answer is option A. There are three pairs. I hope this is clear. If you have any doubt, please ask. Okay, I'm sorry. I'll just explain it once again. So what they're asking is, how many pairs of natural numbers are there such that the difference of whose squares is 63? So x minus y square can be written as 63. So x plus y into x minus x square can be written as x plus y into x minus y. That is equal to 63. And this 63, I've taken it as the factor. I've written it in a prime factorization form. That is 3 square into 7. And this 3 square into 7, I've taken all the possible factors, all factors here. 1, 3, 7, 9, 21, 63. These are the 6 factors, and to calculate the number of factors, I've used this formula here, a plus 1 into b plus 1. So 2 plus 1 into 1 plus 1 is 3 into 2 is equal to 6. There are total 6 factors, 1, 3, 7, 9, 21 and 63. And this 63 can be written as 63 into 1, 21 into 3, 9 into 7. And these numbers, we have to check whether we can represent it as x plus 1 into x minus y, x plus y into x minus y. And if x and y are natural numbers, then we can clearly say that there is a pair. So first we'll check whether 63 into 1 can be written as x plus y into x minus y. 63 into 1 is 63. So x plus y would be 63, x minus y would be 1, x is 32 and y is 31. So clearly x and y are natural numbers, they are integers. So this solution is possible. So x is equal to 32 and y is equal to 31 is one possibility. So if you take 32 square minus 31 square, you would get 63. That is one pair. Then the second pair, we have to see 21 into 3. I have taken 21 into 3, x plus y is equal to 21, x minus y is equal to 3. Now I have calculated what is the value of x and what is the value of y. The value of x is 12, the value of y is 9. So even in these cases, the values are x and y are natural numbers. So 12 square minus 9 square would give you 63. So again, this is one solution. So this is one pair. So one is x is equal to 32, y is equal to 31. The another pair is x is equal to 12, y is equal to 9. The second pair. Now the third pair, that is 9 into 7, we have to see whether that can be represented as x plus y into x minus y. X plus y is 9, x minus y is 7. So 2x would be 2x is equal to 16, x is equal to 8, and y is equal to 1. Again, these two can be our whole numbers or natural numbers. So the other set, the third set would be, that is now again 8 square minus 1 square would give you 63. So there are three pairs of natural numbers whose difference of squares would give you 63. That is, here in this case it is 8 and 1. So 32, 31, 12, 9, 8 and 1. These are three pairs. I hope this is clear. Okay. We will move to the next question then. Take 2 minutes to solve this question. We'll cover here. That day when I was explaining the rules for divisibility, I gave you one rule, and there is one more rule for divisibility of a 7 to find out whether any number is divisible by 7 or not. So what we have to do is we have to take the set of three numbers from the left, like this. This is one set, this is one set, this is one set, and this one. So from the left we need to take three numbers set, and then alternatively this would be plus and this would be minus, plus and minus. So if we take, this is 3, let's change the color. This is 3, 7, 9, 8, 1, 2, 5, 3, 6, 9. So we have to make three sets here, three digit sets. This would be plus, this would be minus, this would be plus, and this would be minus. This is the rule. You have to take plus, minus, and minus, and then we have to add these numbers. And then whatever the number you have, final number, if that number is divisible by 7, then this whole number would be divisible by 7. So they are, in this question, they are saying that this number is already divisible by 7. So when you calculate the final number, that number should be divisible by 7. So if that is divisible by 7, what is the value of P? So what we'll do is we'll take this number 369 minus 25 into P, sorry, 25P. This P digit we don't know. Then we have 981 minus 37. So if we'll bring all the plus signs together, this is 369 plus 981 minus 25P minus 37. We'll add this 369, 981. Mm. 13. One 1350, and I can write, this is 1350. I can write this 25P as 250 plus P minus 37. And when I open this bracket, this will be 1350 minus 250 minus P minus 37. And this will be minus 250 and minus 37 is minus 287. If I subtract 287, 10 minus 7 is 3, 10 minus 8 is 6, so 1063. So this is 1063 minus P. Now this 1063 minus P, they are saying that this number, this whole number is divisible by 7. So this 1063 minus P also should be divisible by 7. That is the rule. When you find out this whole number, add the sum. That is plus 369 minus 25p plus 981 minus 37. This whole number, when you calculate this should be divisible by 7. If this is divisible by 7, the whole number is divisible by 7. To make this divisible by 7, we know that 1063 divided by 7 so 7 ones are 7 5s are 7 ones are, and then the remainder would be 6. So 151 into 7 we do get 7 ones are 7, 7 5s are 35, and 7 ones are 7 is 1057. So 1063 is 151 into 7 plus the difference is 6. 1063 minus 1057 is 6 minus p. So this part is divisible by 7. We want this to be divisible by 7. So if this has to be divisible by 7, so 6 minus p would be 0, because 0 is also technically a multiple of 7. So 6 minus p is 0, so p would be 6. So this implies 6 minus p is equal to 6. 6 is equal to p is equal to 6. 6 minus p is 0. So hence, to make this number, this big number, divisible by 7, p has to be 6. So the correct answer is option B. Hope this is clear. If you have any doubts, please give me a brief of the solution. So they are telling that the number 3798125p369 is divisible by 7. What is the value of the digit p? So there is a rule which says that if you take the numbers to find out whether this number is divisible by 7, what we do is we take a set of 3 digits from the left to the right. So this is 3 digits, this is 3 digits, this is 3 digits, and this is 3 digits. It can be written as 037. This is 3 digits. And then from the left, we'll start from plus and then alternate plus minus plus minus. And what we do is we calculate the sum of this numbers, 3-digit numbers, and that sum, final sum, should be divisible by 7. Only then this whole number is divisible by 7. So what we have done is we have written 369 minus 25p plus 981 minus 37. So 369 plus 981 is 1350. This 25p I have written as 250 plus p. Because for example 255, I can write it as 250 plus 5. For example 259, I can write it as 250 plus 9. Similarly, I have written it as 250 plus p. And when I open the brackets, 1350 minus 250 minus p minus 37. P is a single digit number here. So 250 minus 37 minus 250 minus 37 is minus 287. 1350 minus 287 would give you 1063. So the final number that is there now is 1063 minus p. And this has to be divisible by 7. Because they've already told that this number is divisible by 7. This should be divisible by 7. This is the rule for the divisibility of 7. So 1063 minus p should be divisible by 7. So now to make this divisible by 7, we need to subtract a number which makes this number, the whole number, divisible by 7. So the nearest multiple of 7 to 1063 is 1057. So 1057. So if we subtract 6 from 1063, it will become 1057. This will be a multiple of 7. So 1063 can be written as 151 into 7 plus remainder is 6. And to remove this 6, we have to subtract it with minus p should be 0. I mean 6 minus p should be 0. The remainder should be 0. So p is equal to 6 in this equation. If I take p that side, p will be 6. So when p is equal to 0, p is equal to 6, this sum 1063 minus p would become 1057. This 1057 is divisible by 7. and the whole number would be divisible by 7. So to make this whole number divisible by 7, p has to be 6. I hope this is clear, Tab. If anyone has any doubt, please ask. Okay, then we'll move to the next question. So take 2 minutes to solve this question. So we'll see how to go about this question. They're saying that a frog tries to come out of a dried well 4.5 meter deep with slippery walls. Every time the frog jumps 30 centimeters, it slides down 15 centimeters. What is the number of jumps required for the frog to come out of the well? So they've given that the depth of the well is 4.5 meters, and if I convert it into centimeters, it will be 450 centimeters. Now they're saying that every time the frog jumps 30, so the first time it jumps 30 centimeters, and then it slides down 15 centimeters back. So the net jump is 15 centimeters. So if I take 450 divided by 15, this would be 30 attempts. In 30 jumps, it will reach the top. But the catch here is on the 20, so we will calculate the 29th jump, where it will be. So if we take 29, so 29th attempt, it will be 15 into 29. That would be 450 minus 15, that is 435 feet. But the problem here is after the 28th attempt, this frog would have reached the height of 420 meters. So if I multiply this 28 into 15, it was a 10. Okay. This is 8. 420. So after 28th attempt, the frog would be at the height of 420. And the 29th jump, it directly takes 30 centimeters. So from 420, it directly goes to 30 plus 30. It will reach 450. So it will reach the top. It will jump out of the well. There is no question of sliding back again. There is no sliding. So the number of jumps that is required is 28 plus the last jump. That is 29. So the number of jumps that is required is 29. The correct answer is option B. I hope this is clear. We had a similar kind of problem earlier also, I think, in Zebra's word problems. So if everything is clear, please let me know. I'll move to the next question. Okay, we'll move to the next question then. So take 2 minutes to solve this question. Okay. A boy plays with a ball. He drops it from a height of 1.5 meters. Every time the ball hits the ground, it bounces back to attain a height of 4/5 of the previous height. The ball does not bounce further if the previous height is less than 50 centimeters. What is the number of times the ball hits the ground before the ball stops bouncing? They are saying that there is a ball, and this ball bounces on the floor, and every time it bounces back to 4/5 of the earlier height until it will bounce till the previous height is more than 50 centimeters. Once the previous height is less than 50 centimeters, once the previous height is less than 50 centimeters, it will stop bouncing. So they have given the original height from which the boy drops the ball is 1.5 meters, that is 150 centimeters. So this is the first drop, first time the ball touches the ground. And then after this, this again bounces back, and this height would be, the second height would be, the second height, the first height is 150, the second height is 150 into 4/5. This is 5 3s, and this is 120 meters. So this ball jumps 120 meters. So this goes to 120 meters and comes back. This height is 120 meters. Now the third time it bounces back. This is second time. So after second time, the third height is 120 into 4/5. 5 4s are 24, 16, 1, 4 2s are 8, 9, 96. So this is 96. Again, this bounces back. The ball goes up. It goes to a height of 96. This is 96. This is the third bounce. From the 96 height, it will jump here. So again, it will bounce. So this would be 96 into 4/5. This would be 4/5 is 0.8. So I'll take it as 96 into 0.8. 6 8 is a 48. 4. 8 9 is a 72 plus 4 76. 76.8. The next height it jumps is 76.8. So since this height is 76.8 is greater than 50, again it will jump. It will jump to some height. That height I have to calculate. 76.8 into another 0.8. 76.8 into 0.8. This would give me, it is a 64, 6 8s of 48 plus 4, 52. Uh, 48 plus 6 is 54. 7 is 56 plus 5, 61. This is 61.44. This is 61.44. So this is 61.44. So again this ball will jump. This is 150, 120, then 96, then 76.8, and then 61.4. And if I have to again multiply this by 0.8, the next time it would jump. This time it jumps 49.15. So 61.44 into 0.8. 8 for the 32, 8 for the 32, 35, 3, 8 ones are 8 plus 3, 11, 6 8s are 48, 49, 49.152. This is 49.152. And after this, because this height is less than 50, this ball will not jump after this. So this is the last time it touches the ground. The last time it touches the ground. Now they are asking, what is the number of times the ball hits the ground before the ball stops bouncing? The ball stops bouncing here. If the ball stops bouncing here, before this, how many times it has hit the ground? 1, 2, 3, 4, 5. It has hit the ground 5 times. The answer is B. I hope this is clear. If you have any doubts, please ask. If it's clear, we'll move to the next question. Fourth time it is 56. No, it is 76. 96 into 0.8. 76.8. So fourth time it is 76.8, not 56.8. It is 76. This is 76.8. How to calculate that? 96, the previous height, into 4/5. 96 into 4/5 is 0.8. 0.8 if you multiply, this is 76.8. Is this clear? See, we have to multiply this 96 into 4/5. 4/5 is 0.8. I've taken this direct number directly, 96 into 0.8. Even if you do this, 96 into 4 is 384. 384 divided by 5 is 76.8. So this 4/5 value is 0.8. Okay, you may have made a calculation mistake, Shweta. Just check once. So we'll move to the next question then. To take 2 minutes to solve this question. So consider all 3-digit numbers without repetition of digits obtained using 3 non-zero digits which are multiples of 3. Let S be their sum. Which of the following is or are correct? The first statement is S is always divisible by 74. Second statement is S is always divisible by 9. So we have to form 3-digit numbers, and the digits that we have to use is non-zero digits which are multiple of 3. So single digits which are multiple of 3 is 3, 6, and 9. So using these 3 digits, we have to form 3-digit numbers here. This 369, and one more is 396, and these numbers cannot be repeated. So we cannot have 333, 333, 333. It can be only used once. And then we take this 6 here, is 39 and 93. If I take 9 here, this is 36, and 9 is 63. These are the 6 numbers. So 33, 369, 396, 339, 393, 936, 963. See, these are the 3 numbers, and they're asking what is the sum of these numbers. The sum of these numbers, or what I can do is to calculate the sum. So every digit here appears twice. 336699. So just like the way we used to do this XYZ, 100 into Z plus 10Y plus Z. So like that, what I'll do is that in this each 100 digits, these digits are appearing twice. So I'll write it as 2 into 3 plus 2 into 6 plus 2 into 9 into 100 plus this thing. Here also each number is appearing twice. So again, this is 2 into 3 plus 2 into 6 plus 2 into 9 into 10 plus last digit is plus 2 into 3 plus 2 into 6 plus 2 into 9. So this would be 3 2s are 6 plus 12 plus 18. Or I can take common here. I'll just take 2 common. So if I take 2 common here out of the whole this thing, this would be 3 plus 6 plus 9. 9 plus 9 is 18. 18 into 100 plus 18 into 10 plus 18 into 1. This is 2 into 18 I have taken common. This is 100 plus 10 plus 1. And then this will be 2 into 18 into 111. 100 into 10 into 1. So 111, I'll factorize this 3. Because this is divisible by 3. 1 plus 1 plus 1 is 3. 337. 337 is 111. So I'll write this as 2 into 18. 18 I'll write it as 3 square into 2 into 3 into 37. This is what the sum would represent. Now they're asking that sum is always divisible by 74. 74 is 37 into 2. So this is divisible by, plus 37 into 2 is 74. 7 to the 14, 30 to 6, 7. When you multiply 37 into 2, this is 74. So this is a multiple of 74. So the statement A is correct. Sorry, statement 1 is correct. Then S is always divisible by 9. Yes, S is, there is this 3 square. This is 9. Again, this sum is always divisible by 9. Again, this statement 2 is also correct. So the correct answer would be, select the correct answers using the code. Both, which of the following is are correct? So both 1 and 2 is correct. So if you have any doubts, please ask. Okay then, we'll end this session here. Thanks for coming. Good night, and we'll meet tomorrow at the same time, 8 o'clock. We'll continue